Good afternoon, everyone. For those of you who have joined us, there's now almost 300 people who are on the line. So thank you very much for joining and good afternoon from Geneva, Switzerland. My name is Marisol Estrella. I work for UN Environment Program at the Crisis Management Branch here in Geneva. And it is my pleasure to welcome you to the third webinar under the Global Network on Environment and Oil and Gas webinar series. As you know, UN Environment, for those of you who have joined us previously, we have a partnership with the government of Norway's Oil for Development program, where we are providing capacity building and technical assistance to 14 countries in Africa, Asia, and Latin America on how to better strengthen environmental management in the oil and gas sector, particularly in the upstream sector for exploration and production. While of course, you know, the long-term goal of UN Environment and in the international community is to reduce our reliance on fossil fuels to fight climate change, of course, we recognize that the oil and gas will also still remain part of the global energy mix in the foreseeable future, which is why we continue to work in this sector and to ensure that the oil and gas sector is produced in an environmentally and socially acceptable manner and do not negatively impact on local communities. And as part of our work is obviously then to disseminate knowledge and best practice in this sector through global outreach, such as through these webinars. So it is really my pleasure to welcome you to this particular webinar on oil contaminated site assessments and introduce our speakers who have kindly joined us. May I introduce then Dr. Matthew Richmond. Matt, you can maybe raise your wave so that they know who you are. Matt is a marine scientist who has been working for over 20 years in the oil and gas sector, particularly in the East Africa region, but in other parts of the world. Also, it is my pleasure to introduce Mr. Walid Ali Hussein, who is the manager of the Oil Pollution Unit in the Ministry of Health and Environment of the government of Iraq. I hope we can present to you today a very interesting webinar that focuses on how to undertake contaminated site assessments with a practical example of a recent experience we've done in Iraq together with the government. So perhaps just to give us a little bit of a framework of how we're going to conduct this webinar, we will do the presentations first, and then I will take questions after. So for those of you who are online, there is a question board on the right-hand side of your pane where it says questions, and so you can write your questions. If you click on that arrow, it expands and you can write your questions there, and I will track some of the questions that you are posting. Okay, and then I just wanted to let you know that this webinar is being recorded so that we can then in the future upload it on our YouTube channel, and you can rewatch it at your convenience, and also share it with your colleagues. Also, just to let you know that at the end of this webinar, you can receive a certificate of participation by clicking on a survey link that we will send to you at the end of the webinar. So if you would like to receive the certificate, it's important that you fill in the survey questionnaire, and then you will receive the certificate. Finally, I just want to introduce a fourth member in our team today, but we don't see her, but she's definitely in the background because she's the one who makes everything work for the webinar, and that's my colleague, Ms. Chidima Zikoria, who is also here in Geneva at our office. So I don't know, Chidima, if you can show yourself, just say hi.
Hi, I'd like to show myself, but my webcam is having issues at the moment. Okay. But I'm here.
There's Chidima. So without further ado, I would like to ask Matt to please go ahead. So Matt's presentation will help provide a sort of overview and general framing of what it means to undertake contaminated site assessments of hydrocarbons. So go ahead, please, Matt.
Okay, good afternoon. Do you see my screen, everybody? Yes. Well, good afternoon and good morning to those of you around the world. Thank you for signing up to our third webinar, as my boss Marisol explained. I'm going to give you a run through over the next 25 minutes of basically the main steps involved in undertaking the contaminated site assessment. So this really is an introduction to contaminated site assessment, or CSA, and the main elements are what actually is a contaminated site and the types of contaminants, and what are sources, pathways, and receptors, and the contaminated site assessment framework. Oil in the value chain and contaminants and their impacts will be covered, as will the preparation of a conceptual site model, or CSM, and sources of errors related to sampling. Health and safety, sampling, planning, and preliminary site assessment will then be followed by what's involved in a detailed site assessment and the analytical techniques involved, and then concluding with the introduction to risk assessment to then guide the remediation. So in short, from identifying a contaminated site to beginning the process of considering remediation of the site. The actual methods and techniques involved in remediation would then be another webinar at some future time, and that is a large topic. So common contaminants in land and water. Well, as some of you are aware, I've shown this screen here. I hope you can see it all. There are a number of contaminants, and the ones that I've outlined in yellow are the ones which are mainly related to the oil sector. So of course we have air contaminants through smoke and exhaust. We have carbon dioxide, carbon monoxide, and then a big emphasis is on oil and gas leaks and spills. And then what penetrates into the ground through naphtha and benzene. The real focus of the contaminated site assessments related to the oil and gas sector come from oil and gas leaks and spills and penetration of those products into the soil. So as I've said, contaminants can be present in water, so that's drinking water, through reservoirs underground, or in lakes or rivers. Contamination can also be present in the soil through farming, or the soil through which the water percolates, and contamination can also be in the air. And here's a few signs you might find if you go around the world and you visit contaminated sites. Contaminants get into food, gets into fish, shellfish, it can get into vegetation, and it can get into the soil, which affects the people who are working with the soil or maybe living above the soil. Some examples, visible examples of fresh contamination. So here's a few pictures from the Niger Delta in Iraq, where there have been oil spills related to accidents, related to sabotage, related to theft, related to conflict. And Walid will give us an interesting description of a whole process taking place in Iraq at the moment, looking at a number of contaminated sites throughout the country. But it's not only in the Niger Delta in Iraq. Around the world, there are contaminated sites in most countries. In the UK, there's between 5,000 and 20,000 problem sites. And in the UK, in the USA, there's between 640,000 and 1.3 million facilities where there is a contaminated site issue. Now, a lot of these are relatively small sites, maybe an old petrol station or old dry cleaners that has been leaking product into the ground, which contaminates the water table, whereas other sites can be much larger, resulting from a major spill or a major conflict. In the oil and gas value chain, if we think about upstream, midstream, and downstream, some of you are familiar with these terms. The upstream oil and gas activities are to do with exploration and potential products which will get into the ground, the air, or the water are toxins, radioactive compounds, oils, surfactants, fuel from vessels, from rigs at sea or on land. Then midstream, we tend to get fewer products, but in bigger volumes moving around the world, transported on vessels and pipelines or in storage tanks. And then downstream, all the thousands of petrol stations around the world and all the small tankers driving between them. Mostly it's refined, can also be crude oil. And as I mentioned, transportation, vehicles, buried storage tanks and pipelines. In the oil and gas sector, we mustn't forget the supporting industries. So they also have waste facilities which tend to include quite a lot of toxic and oil waste. So all these factors, all these stages of the oil and gas value chain can potentially contribute to contaminated land. And as we begin this lecture, the things we need to think about is where and what. We need to think sources, pathways, and receptors. These are the fundamental three elements that are involved in making a contaminated site assessment. What is a source? What is a pathway? And what is a receptor? Now, when we conduct an assessment, there is actually a structure, and most people around the world follow a similar sequence, often about 5 steps. So when a contamination is discovered, the first step in general is to notify the regulatory agencies and the affected public. So if an oil spill is identified or a contaminated well is identified, the initial step is notification. Then the next step is to conduct a preliminary site assessment. Now this tends to be a fairly short exercise. It may just be half a day or a few hours at a site, and there is a sequence of data to collect from a preliminary site assessment. Walid will be telling us about how they undertook a number of preliminary site assessments throughout Iraq. As a product of the preliminary site assessment, we want to draft what's called a conceptual site model. So the conceptual site model gives us an idea of where the source is, what are the pathways, and what are the receptors. Attached to that is the beginnings of a risk assessment, where we consider what the risks are of leaving the contaminant as it is, what are the risks to the receptor, and how those risks can be mitigated to the point where there is a negligible risk and humans and other receptors can carry on living or working in the area. Step 3 and step 4 and 5, we won't be talking on in this lecture, but so you know, once you've drafted your conceptual site model and began the risk assessment of a site, you'll start to prepare what's called a remedial action plan, or RAP. This basically outlines how the site is going to be cleaned up, what's involved, what's going to be removed, and what's going to be left, and where it's going to go. That all goes into a very detailed plan, which is prepared by experts who do this. From there, once that's approved, the implementation of the RAP begins, and that often will involve treatment of the contaminated product, the soil or the water, with removal of the material or the treatment on site. There are different methods to treat contaminated land, particularly, and water, and often they take many months, and some of them what are called biological, and they're using bacteria and oxygen to increase the breakdown of the contaminant. Other ones are more physical, non-biological, where the material is removed and solvents are then used to clean the soil. Finally, once the site has been remediated, there is what's called a site closure report, which is sent to the regulator. They approve it, they check it, they verify it, and there may be ongoing monitoring required, so the land can then be used for an additional purpose. So that is the summary of a contaminated site assessment framework. 5 major steps, and the focus of this webinar is on the first 2 steps. A preliminary site assessment. This is when you first visit a site and you follow a checklist of tasks and data which you need to collect. Usually we use a form, and we've developed a form that we've used in Nigeria and we've used in Iraq. It's based on a background of desk study, and on site there are visual observations. Speak to local residents who might have been there at the time of an incident, who can give you some information about what happened, what the weather condition was at the time, which way the wind was blowing, things like that. And then you start preparing a draft conceptual site model. In this graph, you can see here, there's a planned version of a conceptual site model, which shows these various different colors from pinks to blues and greens, which are different concentrations of the contaminant. So this is drawn as a map in plan version. The conceptual site model is very important in understanding what's going on the site. And you're not going to get it right first time, but this is an iterative process. It'll improve as more information is produced. But it describes the characteristics of the site and will show the relationship between the source, the pathway, and the receptor. It'll allow subsequent investigations to take place. And it is a requirement for site investigations. It provides a context for quantitative risk assessment. And it demonstrates that those who are working on the site begin to appreciate the problem of what is going on in a 3-dimension. It's a fantastic tool for communicating with other stakeholders, and it's a good quality assurance tool because you can return to it as you gather more information and improve it and improve it. Again, the key terms are source, pathway, receptor. For example, an oil spill in a river, oil entering drinking water, and people drinking the water. That's a very simple version of a source-way, pathway, receptor link. This is a slightly more sophisticated drawing. This is in profile. So we have the pathway and the source here on the right of your screen. There's an oil spill, oil tanks which have spilt. Some of them are vaporizing. And then the people are the receptors in this case. And the oil can penetrate through the soil. There are parts of the oil that stay above the water table, and there are other parts of the oil that will mix into the water table and will be soluble, and they can be transported into a borehole or a well and then end up in drinking water. So once again, the source pathway receptor linkages are shown in this profile version of a conceptual site model. This is another simple one for a conceptual site model in a lake. And here we have the contaminated sediment is the concern. So the contaminated sediment is in the bottom, and it is affecting the water. It is affecting the marine, the aquatic life, and including the life which is semi-terrestrial, like the shorebirds and the otter and the turtle. So the arrows indicate the flow of, in this case, contaminants. Conceptual site models for aquatic environments tend to be quite complex because often the water is moving. So it's not a static system. Conceptual site models for land that do involve water, which is a high risk area, also move, and the contaminants can be transported many kilometers away from the actual source. Some of the exposure pathways related to the oil sector are soil, which could be directly contacted by construction workers and residents, leaching into groundwater, as I've said, or nearby surface water, and runoff, and then direct contact with plants and animals. Groundwater for drinking, of course, but also vapors that can migrate from the groundwater into overlying structures. For example, you could have a shallow well or shallow groundwater with vapors that are moving up through the soil into housing areas. Surface water, obviously, as illustrated, and air and vapors, which can expose utility workers and other residents. So those are typical exposure pathways at oil contaminated sites. Oil in the environment and its behavior. Well, oil doesn't stay as oil as soon as it's released into the environment. There's a process called weathering. So fairly quickly, depending on the climate, the type of the oil, the other properties of the soil and the oil will be weathered, and it will change. Generally speaking, in a warm environment, a lot of the volatile organic compounds will be released into the atmosphere, and the oil will basically become thicker and thicker. Depending on nutrients and oxidation and other processes, the oil will break down over time. But some oil spills in certain environments will rapidly thicken and harden into tar sheets, and then they will persist for many decades. This weathering template on this slide can be applied to soil, fresh water, seawater, where some of these parameters are slightly different, but basically the process is the same. Oil will weather and break down very, very slowly over time. So when you find a contaminated site, where do you sample? It can be a bit mind-boggling. You see some oil in a lake, in a wetland, but you don't know where to begin. Well, the golden rule is don't save money on the assessment stage. Put all your effort into the assessment, because you'll then save a lot of money on the remediation. And remediation is very, very expensive. So it's good to get your assessment correct as best as you can before you decide how to remediate the contaminated site. Now, getting the sampling process correct involves sample design. You could just go out there and take a few samples of water and a few samples of soil and think, okay, I've done my job. But there may be a lot going on that's not visible. So it's a good idea, and it's becoming standard practice, to set up a grid across your contaminated site based on the conceptual site model that you've already designed. You have an outline of what you think is a contaminated area. That's your theory of your contaminated area. And then you can set up a grid, and within that grid, you can do random sampling. Now, the optimization of sampling strategy is another thesis in itself. It's quite complex, and to do it statistically correct, and in some cases subject to legal scrutiny, the most widely accepted is a systematic grid and random grids of a method to sample. Once you've done your sampling, once you've done your grid and you've decided your sample strategy, then you need to prepare. And that involves everything from labeling and forms and tools and sample bags and containers and tape measures, GPSs, cameras, setting out your sample area, your sample site, and then you're going to get on with the actual detailed sampling. I'll just mention that in the preliminary site assessment, you don't collect any samples. That is just a preliminary visit. It's more like a screening. When you get into a detailed site assessment, that's when you collect samples. So just as an overview, reminder, when you're considering your sample planning, it's good to define the problem, the objectives, which will then help design your sampling approach, your quality assurance, which pollutants are you looking at, the physical and chemical conditions of the pollutant, on and so forth, right down to personal protective equipment, sampling tools, storage, transportation. And the end point in all of this is getting your samples to a laboratory. We have to get the samples to a lab that is an accredited and reliable laboratory that's going to give you the right results. And based on that, you decide whether there is a need and what type of remediation will be required. So just a few pictures here to show you the typical kind of equipment we use for sampling. On the left, you can see all sorts of augers and marker flags and sample jars and sampling tubes. That's for collecting your material. There's some gentlemen doing that in parts of the Niger Delta, labeling their jars, keeping them in a cold box, sampling water, sampling from sewage systems, taking core samples in contaminated mud, using a probe to sample in rivers, and taking water, surface water from rivers. So all these are different ways, depending on where you are in your environment, the kind of equipment that you'll need to actually collect your sample. And you need to be sure that each sample needs a special bottle type. So for example, petroleum products should be stored in a glass container. Why is that? Because if you put any kind of contaminated soil with petroleum in it in a plastic container, there's a possibility that you'll get some contamination from the plastic into your sample. Other things should go into you can put water samples in plastic and metals in plastic bottles, but for pesticides, for microbial activity and petroleum products, you should use glass containers. And the sample should reach the laboratory as soon as possible, hours and days max, not weeks. And one thing that's important to understand with labs is that a lab is accredited for a particular analysis. There are no labs that are accredited for every single analysis. And there are hundreds of different analyses depending on the types of contaminants you want to have determined. So different labs use different procedures, and you can send the same sample to different labs and you will get a different result. So it's important to be consistent with your lab to understand which method they use, which procedure they're using, are they using the right kind of solvents, or the solvents within date, all kinds of things like that. Once you've got your samples and you sent them off, it's good to have what's called a chain of custody documentation. So this is a table, usually. It's often supplied by the laboratory that's doing the analysis. And you detail all your samples, the numbers of vials, the dates, all the rest of it. So they'll receive that and they'll tick it off to make sure and confirm that they've received all the material and also when they received it. So it's a quality assurance process that helps you give confidence that your results are going to be meaningful. Now, there's always uncertainty, but if you look at this arrow, the laboratory uncertainty is the lowest. The greatest uncertainty is you have a site that's heterogeneous and you're missing some of the contaminated land. That's why it's good to have a kind of broad approach to looking at a site. Then going down sampling area, cross-contamination from handling and storage. These are the ones that's kind of human error, really. We can all avoid that by sticking to the best practice on how to look after your sample, how to label your sample correctly, using the right kind of glassware, keeping the material refrigerated, getting it to a lab on time. So it's important to notice that, and the errors, they can compound, and the more errors you get in your sample and your data, the less meaningful will be your result. Once you've got your data back, it's worth going back to your site model to see whether you haven't missed anything. Do you have the details of the migration pathways? Which of the pathways are potentially active? What are the critical receptors? Have you considered all the potential pathways? So it's good to look at a kind of sketch like this to make sure that you really haven't missed anything. And as you gather more information, you should return to your conceptual site model and adjust it. It's normal practice. It should be reviewed, refined, and revised in response to additional information. Now we're getting to the end now, and one of the things that are part of the last stages of the contaminated site assessment is the risk assessment matrix. What I mean by a risk assessment is you want to work out through the whole process of sampling that you get to the bottom end of this table on the right-hand side where the risk becomes negligible. And if we start on the left, we've got the source. So let's say here we've got petroleum hydrocarbon compound. This is a site where there used to be a petrol station and the soil is contaminated and the developers want to make it into a residential housing estate. So they've got a problem because they found petroleum in the soil. So the pathway, as indicated in the second column, is the inhalation, the ingestion, migration of the surface runoff, migration by liquid flow, and plant uptake. Those are the pathways that the contaminate can reach the receptors in the third column, which are the workers, the end users, site workers, the end users. In this case, the end users will be the new residents of the residential housing. So we've got your receptors. Your initial assessment has determined that the risks, the severity is from medium to severe and a few minor for plant uptake. The probability for most of them is low, of a low likelihood or unlikely, but nevertheless, the risk is moderate to low for most of them. But moderate to low is not good enough for housing. So we need to do more. So once you've done your ground investigation here in the middle column, findings of the GI, the analysis has determined that you've got elevated total petroleum hydrocarbons and a number of other compounds. And it's determined that these contaminants are a result of tar, basically coal tar fragments that are within the soil. And it tells us a bit about the type of soil and that there's no indication of contamination within the groundwater or the stream. So the findings of the study, the detailed assessment, have determined that the contaminant, in this case, is restricted only into the soil. And therefore, there aren't any other hazard linkages, and that the revised risk is still moderate to low for a few items. And that leads us to the need for reclamation. And the reclamation approach in this case is that all tar macadam has to be removed from the site. Now, this would require probably several meters need to be excavated downwards until there is no more tar macadam left, and it has to be removed and treated. Once that is done, you would end up with a residual risk of negligible. So this table of the risk assessment shows the whole process from moderate to low risk to negligible and the steps in between.
Hello?
Once you've done that, the property has been cleaned and we can apologize for any inconvenience caused. Thank you.
I can't hear you. I can't hear you in the webinar.
Great. Thanks very much. Thank you very much, Matt.
I have a sound in my microphone.
I would like to, Mr. Walid. Mr. Walid, I would like to now check with you whether you can hear me.
Yeah, I hear you.
Excellent. Do you have control? Can you upload then your PowerPoint, and then unfortunately we've lost visual with you, but we can hear you now. And I think if you talk, you can talk through your presentation. Are you able to upload your presentation now?
Yeah, I am ready to introduce my presentation. Is that
Great.
okay?
I will ask. Chidima is now going to switch presenter. So she will switch presenter to your screen. So just for those of you who have joined us just a few minutes ago, thank you again. We have just finished the first presentation, and we are now about to start the second presentation, which then provides a practical example of how we have been able to apply some of these conceptual framework for site assessments in Iraq. So I hope now we're ready for presenting the second presenter from Iraq.
Okay.
Go ahead, Mr. Walid, and share your screen.
My presentation is a report carried out in Iraq from September to December 2018. Introduction: wars and conflicts have a serious effects on the lives of societies, like destruction of infrastructure and incoming source of population, impact of society because of migration as a result of destruction houses and cities, health effects, also have environmental impacts due to the spread of chemicals and biological, also military building. Iraq suffered for many years from wars and conflicts, so there is a large number of oil contaminated locations from north to the south of Iraq. This is increased when terrorist activities has begun in Iraq from 2000 and still continues. Pollution in Iraq result from many reasons. First, development work and rising production rates in the oil fields. Iraq now have maybe more than 4 billion barrels in a day. This make pollution and environment. Also, there is a weak infrastructure in the pipelines, networks, and pumping station. Weak environmental management. Also, terrorist and criminal acts. As a result, there is many extent of oil spill have recorded in a year, especially in the north governorates of Iraq. Drivers of oil contamination in oil result from two reasons: poor environmental management in oil sector and pollution caused by the terrorist acts and security conditions. Oil pollution caused by terrorist activities. There is a different for terrorist activities in Iraq from 2000 to 2014. In that time, the terrorist acts, the pipelines of the crude oil and products. So many locations have contaminated, especially in Nainawa, Salahuddin, and Kirkuk. After ISIS coming and after 2014 and the liberation operation, the terrorist operation be more complex and expanded. The terrorist acts oil refineries operating in Nainawa and Salahuddin Governorate, which case the destruction of Pager refinery, one of the largest refineries in Iraq, as well as refineries of Kayara and Kesek. Also, there is oil wheel burning in Kayara, Shirgat, in Zala, and Nainawa, and Ajil Allah's fields in Salahuddin, also in the oil field of Kirkuk, where about 50 oil wheels are targeted in all these governments. Destruction of several pumping stations and pipelines. This is a picture for oil pump station in Iraqi Turkish strategic expert line, and you can see the volume of destruction and pollution caused by terrorist acts. Assessment for oil pollution location. With technical cooperation from the United Nations Environment Program and support of Norway, the government of Iraq carried out a rapid environmental assessment for oil contaminated sites in the liberated governorates, Nainawa, Salahuddin, Kirkuk, and Diyala. 74 faulted sites were visited and assessed. 21 sites were identified as a high-risk contaminated area required immediate treatment due to the environmental and health, security, and social risks. Preparation of environmental map of oil pollution. So we need in Iraq to put on of oil pollution location in the north of Iraq for the liberated governorate. And for that reason, a technical team was formed from Ministry of Health and Environment, technical directorate, which was 6 persons. Also, 2 persons from Ministry of Oil, North Oil Company, and North Oil Refinery Company. There is a supporting team from the Environment Directorate in the Governorate of Nainawa, Salahuddin, Kirkuk, 3 persons. The aim of the team was to visit by tourist activities, which was 38 in Nainawa, 15 location in Salahuddin, 19 in Kirkuk, and in Diyala. The purpose of the team visit is to identify contaminated site coordinates, determine the size of contamination, identification of cases of pollution, determine the type of pollution in the site, risk assessment and effect, identify the potential respectors, location photography. Data and information collected from the field team go to the information system department in the Ministry of Environment to prepare a GIS map for all contaminated sites in Iraq, in the north of Iraq. This assessment was carried out by a special form which is developed together with the UNIP and governance ministries in Iraq. The same assessment forms was used for all sites visited. Field work was carried out within 12 days and in the rate of 12 hours per a day. How to site visit is evaluated according to several variables based on the evaluation. The site is classified as in the term of risk and importance of the treatment. As I said, 21 high-risk location evaluated. All information has been included in a matrix containing a sample to facilitate the classification of these sites. This matrix was according to the formula prepared in agreement with experts. The information contain geographical information, which is nature of geographical location, coordinates, climate, plants, and animals. Population information included the number of people, type of living, and the human activities. Environmental information, type of pollution, quantity, current and potential environment impact, respecters, which air, water, source, and soil. Losses and damage, including farms, animals, source of income, direct effect on the population. The most important site identified where there is the 23 wheels destroyed in the Al-Kayara oil field, and also the pipelines, pump station, which is the case large oil spill in that field, and have a direct impact on population and water. Also, we have Ajil and Allah's field, counting about 10 oil wells destroyed, with pipelines and pump station, causing a large oil spill, environmental and security, high security risk in that field. Also, Al-Kayara oil refinery, many of production units, pipelines, treatment plants, pumping station have been destroyed. Also, Al-Kasak oil refinery, many storage tanks in that refinery have been destroyed, pipes and pumping station, treatment units, and this case, the large contaminated area, which is have a direct impact on the water resource in that location. Also, we have a pipeline crossing the Tigris River in Beji. This destruction of this pipeline casing large oil spill in that region. The Iraqi-Turkish strategic line for export of oil, which have been destroyed, the pipeline and pump station, and each location in that destroyed have a high risk because of oil spill in Kirkuk, which is environmentally critical areas for human activities and water source pollution. This picture from Kirkuk, Al Hawija, and you can see the volume of oil spill which is in the river. This river used from the population for human activities and also for grazing and agricultural activities. And you can see the pollution in the main stream of the river and also in the nearby lands from the river. This is a picture from Nainawa Al-Kayara, and you can see here the oil wheel fires. And if you have attention, the housing which is located nearby the oil field in Al-Kayara. This is in the oil refinery in Al Kayara, and you can see the oil spills and destruction in that refinery. And this is in Allas and Ajil oil field in Salahuddin. This is the oil spill in that field, which is affected in the grazing activities for human health and economic social impact. We have known that this terrorist act have increased the rate of respiratory and skin disease among the local pollution. Pollution of grazing area with oil spill leading to livestock losses, contamination of water source use, which is lead to damage in the crops of farmers in this area, increasing rate of population migration from affected area and due to the lack of economic resource and security risk result from the spread of oil spills. This is the GIS map. This is for Nainawa, and you can see how many locations the field team have been visited and the classification of each site from the environment sensitivity and security condition in each location. Also, this is for Salahuddin, which have 15 location with some location have a high risk from environment and security condition. And this is for Kirkuk. The main contaminated site was in Al Hawija and Al Zab, where this contaminated sites have a direct impact in the environment and human lives. Also, we have two locations in Diyala which have low environment sensitivity and low security condition in that location. This is the matrix I speak about it, and you for each for environment sensitivity, also for the weather, security condition, and the classification of that for each location in that table. This matrix help us to classification what is the high risk locations in the north of Iraq, which was 21 sites from 74 sites visit. Current and future action. The North Oil Company have some treatment to the and remediation for some location in the Kirkuk, especially in Kirkuk.
Are you able to pass the slide? Can you pass to your, oh, there. Okay, very good. Thank you. Sorry for interrupting.
Okay. The North Oil Company have some treatment for contaminated sites in some location, and especially in Kirkuk. Also take security measures to protect the contaminated sites from terrorist operation. Provide decision makers with the result of evaluation and recommendations. Follow up position by environmental teams with database update. Follow up field training on contaminated site cleanup and remediation, which is being planned together with Norway and UNEP in next September. What we need, due to the large number of contaminated sites and the size of pollution, there is need to special project from the international community to support Iraq. To support Iraq effort to remediation this site and as these sites represent environmental, social, health, and security risks. An integrated plan should be adverse to remove the pollution and the result negative effects and provide the necessary technical support for environmental assessment teams to enable them to assess risk across all contaminated sites and area in the country based on assessed level of pollution. Thank you very much.
Thank you very much, Mr. Walid. I apologize that you were having some difficulty with the Wi-Fi, but at least we managed to hear almost all of your presentation. So thanks very much. You can still hear us, right, Mr. Walid?
Yeah, I am with you.
Great.
Okay.
So I think thank you for both presentations, and I think now we have time to answer some questions. And there are a number of questions that have already been posted on our platform. So perhaps I'll start with Matt. In revisiting, like you had presented earlier, the sort of the framing in terms of conducting the risk assessment based on looking at the source, pathway, and receptor. And I just wanted to ask you, in your experience, is the receptor always generally then humans in terms of identifying who the receptors are? And how do you further classify, if you just say humans, and then how does that, based on your understanding or experience, how is that further broken down from that perspective? You're unmute. You can unmute yourself. Yes.
Thank you. Thanks for the good question. Well, in the UK, when we consider humans, the standard receptor is, I believe, it's considered to be a 4-year-old playing in short trousers with no socks and shoes on in a garden. So there is a kind of standard module as a receptor in the UK, and a lot of other countries in Holland, they have similar kind of things. But not all receptors are human. Some receptors might be a protected area, for example. So there's a certain sensitivity, and that has to be treated on a case by case, depending on the pollutant. So it can be a protected area, it can be a World Heritage Site, an archaeological site, it can be wildlife, that isn't consumed. It can be other marine and terrestrial aquatic species that are not eaten by people, so the receptor doesn't end with human beings. So there are a range that pretty much covers it. But depending on which species are affected, if they're endangered or if they're threatened, then the level of severity goes up and the risk goes up. So
your conceptual site model would basically also then capture that landscape.
You tailor your model.
Okay.
Yeah, so you tailor your model to the habitats and species.
Right. So then maybe I'll just ask Mr. Walid, in Iraq, I mean, what were the different, like I think you elaborated on the different sources of contamination, especially those linked to from the conflict and terrorist activities. So I think that was very clear. Would you like to elaborate on what your team identified as the main sort of pathways of the contamination and the different receptors? Like if you can characterize, you mentioned residents, but if you could, would you like to elaborate further on the various receptors that you identified in these contaminated areas in Iraq?
Actually, can you hear me?
Yes,
Okay.
now I can hear you. Yes.
Actually, the formula, which is put it from our team and UNIP, was very useful to identify the pathway and the receptors for each location. And make the matter very easy. Each location have 15 to 20 minutes to have a rapid assessment. So the mean receptors from location was the human activities and the environment surrounding in the each location and also the nature of that location from maybe climate and also the security condition in that.
So I think you also mentioned livestock, like grazing areas that were impacted. So that could also be then identified as a receptor. Is that right?
Sorry, can you repeat your?
In terms of defining the different receptors, I think you mentioned, in addition to people and residents near and around these contaminated areas, you also mentioned grazing areas for livestock being affected, correct?
Yeah. Especially in Al Kayara oil field, we see many grazing activities inside the field, and I see a livestock directly for the animals because of oil spills in that area. In one location, I see about 20 sheep died in oil spill in one location.
And is it usually is the contamination usually spread by land or also by water bodies in Iraq, in what you've seen?
Yeah, it depends on the location. If the location is near the rivers and rain streams, maybe the pollution contaminated the water source, especially in Tigris rivers, in Beji, because of crossing piping in that area. Also in Al I see many water wheels, which is used from the humans contaminated by the oil spill, and this is affected on the human lives.
Yeah. Okay. There were actually, so this actually then ties to my next question, and these are some. This is also a question that was raised in the platform by participants. In terms of the criteria that is used for classifying the level of severity or sensitivity. So Matt, maybe could you elaborate a little bit on, how does one identify, develop the parameters or criteria for determining the level of severity? Because I think we've seen, let's say in the Iraq example, we tried to find a very simplified way of ranking low, medium, high, the sensitivity or severity of contamination. So what is behind that, though? Like what type of criteria is considered?
Right. Well, again, based on UK, I think the US also, and the Dutch and others have developed what they call generic assessment criteria. So for every single contaminant, there is a value at a concentration that is as a threshold beyond which it becomes a hazard. Again, it's based on a kind of 4-year-old child wandering around in shorts and no shoes, and playing with soil and that kind of thing. So it's quite a complex assessment. The criteria are defined beyond which that contaminant has to be removed, and it doesn't allow you for residential purposes, for example. So for residential land, there is a list of contamination values which are tolerated for a suite of hundreds of toxic compounds. Whether it's agricultural land, whether it's playing fields, whether it's outdoor recreational areas, there are different criteria. So there are tables and tables and tables that list all the compounds and what level are they permitted.
So
okay, the same thing applies for food. So the same thing applies for water. For the list of toxic compounds, what are the levels that are permitted? And they tend to be in parts per million. I mean, it's that kind of level of quantification.
So that's like one criteria is looking at the toxicity, right? And based on certain values, measurable values of toxicity. But where does the social and environment, well, like the broader environmental considerations come in?
Well, the most accurate, the most well-defined ones are the ones that affect humans directly, through contact and through ingestion. Kids eating soil or food, those are all quite accurately demarcated. It gets a little bit more case by case when you get into an environment, because if you have a contaminant in an environment, let's say in Northern Europe, and you have that contaminant in an environment, let's say in Iraq, the conditions are so different, and the effect of weathering and the other processes that take place in the two different environments are not comparable. So they then have to be studied in detail in terms of each environment. There is no rule that affects all when you talk about the wider landscape.
So maybe I can then now ask, thank you, Matt. I can ask Mr. Walid, how did you in Iraq develop or what type of criteria did you use to determine different levels of environmental sensitivity? Because just keep in mind, maybe just to remind our audience, what they did in Iraq is a rapid assessment. So there was not a lot of time and resources to do a very detailed sampling and assessment. But in your experience of doing the rapid assessment, what was the criteria that you used for ranking the different environmental sensitivities based on what?
Okay, as Mafia said, there is many criteria in each location, and each location tell you what is happening in that site, and what is the criteria. You can see it. You can see it when you reach the site. You can see the environmental criteria and population, weathering. Also, there is some respecters as water source near the pollution sites. Also, is there the volume of contamination in each site. All together make you to take the right decision about this site. Some of as I said, we visit several locations, and some of these respecters, because it's a desert and no water source, no population in that area. Also a limited plants with a limited animals in that location. So this location give you a picture that is a high risk location. And another, you can see human activities. You can see the rivers, water source, and also security conditions. Sometimes all these together give you a picture that this site is a high risk contaminated site.
Okay. So that's very interesting. I mean, because I like to, what's great about having Matt and Mr. Walid here is because then we can really see how some of these things can be applied in sort of real local conditions. And in Iraq, it's particularly very challenging. So I wanted to, Mr. Walid, if you can comment on, what were the challenges that you and your team encountered when you were out there for 12 days, 12 hours per day, visiting 74 sites, which sounds very incredible considering. Maybe you can just give us a flavor of some of the challenges that you encountered, including sampling and how to organize a team, etc.
Yeah, our team have many challenges when we make assessment because of a large area to cover. It's expanded from Turkish boundaries to the Iranian boundaries, from the north to the middle, a very, very wide area. And it's 74 locations. Okay, but governates to cover, and this is and we have a limited time, 12 years, to finish our job. So that was very difficult on our team to get all location. Also, there was a very high risk security conditions. In some location we have mines. In some location we have ISIS near us, and we are targets from ISIS in some location. We have military and policemen together with us to protect us in that locations, which is mean too many coordinates, military coordinates to get in high risk security condition.
That sounds very challenging indeed. So, I mean, for those of you who are listening and are working in sort of oil and gas producing countries and have contaminated sites, I mean, these are some of the things that you need to take into account. So it's not just the technical programmatic part, but it's, also thinking about security and logistics of how to move the teams. And I think you mentioned having to work with the local government officials and ensuring that you have that coordination established, correct?
Of course. We have to coordinate with the military, with the police stations, with the governments and government. We have to coordinate with many companies there, oil company, refinery company, and each location management. But I want to mention some important things that the form from the expert was very useful to us to get our job in time. It's make the job easy to complete it out of these complex conditions.
Yeah,
So
thanks very much. No, I mean, there are a number of questions actually for you. That's why I keep coming back to you on the platform. So one of the things that has also been asked then is, you know, how have you used the results of this rapid assessment in terms of the follow-up? I mean, how is the government using the results? And how are you planning to follow up?
Yeah, our results from our assessment report have been go to Prime Minister, and we have a Security Council in Iraq. Also, we have a copy to the Ministry of Oil, and Defense, Internal Ministry. So together, all decision makers have all picture. What is happening in that location, and what is the risk assessment, and what we need to do in that location. But I think we need more financial support to get finish our job.
Are you working, by the way, are you working with the oil companies in helping with the cleanup, especially in the ones that have been identified as very high priority? And what is their role in the cleanup?
I visit some location and I see oil refinery company. Landfill Al-Kasek, especially in Al-Kasek refinery, landfill without any treatment. We stop them because it's illegal and without any environment instruction and laws. So some location I see the companies landfill and didn't treat this soil and the source of contamination.
Okay, but in terms of the other areas where you have been as a result of the conflict, are the oil companies at all supporting in some kind of cleanup or in follow-up to the contaminated site assessment?
Yeah. Let me clear something. The oil companies have a limited ability to remediation all these sites because it's very, very huge work and need support, technical support, also training equivalent, these all together. And also we need a political decision. We need also a military support to remove mines in that location and protect workers and companies from ISIS attack.
Yeah.
This the challenge together, and so it make too difficult to remediation and the treatment this sites.
Okay, thank you very much, Mr. Walid. I mean, and since we have on the subject of cleanup and remediation, and there are some questions on the platform that talk about remediation, maybe I'll turn to Matt now just to comment a little bit on your thoughts on, once say you've done the contaminated site assessment, you have an idea of which areas have been prioritized, what next? I mean, I know that this webinar is really focused on the site assessment, and we will at some point have a broader discussion, another webinar on remediation. So, stay tuned. But since there are questions related to, remediation and what are the best options for site cleanup, maybe I'll just ask Matt to just comment on that now.
Okay, thanks, Marisol. Yeah, a good question. Not surprising that question comes now. As I said at the beginning, it's a whole nother study. There are at least 30 techniques for cleaning up contaminated soil, and there's at least 30 techniques for cleaning up contaminated groundwater. So they generally break up into two different types. One of them is biological, and that can be anything from planting trees which absorb certain heavy metals, to non-biological, where you get in there with lots of trucks and you physically get all the soil out and take it to a treatment plant and then bring it back again. Now, and there's everything in between, and there can be a mix of match. It really depends on the conditions, it depends on the contaminant, it depends on the time frame over which you want to do it, it depends on what you want to use the land for afterwards, because then different criteria will be effective. If you want to use the land for housing, then we get into the most conservative criteria in terms of contamination across all the spectrum of chemicals. So it does vary a lot. It varies a lot from country to country. The costs vary a lot. It depends on the distance to the site from where there's infrastructure. There's so many features that come into it that you cannot generalize. But it does cost thousands of dollars per cubic meter. It can be tens of thousands depending where it is and what's involved. It's quite a fascinating science, and it's open to entrepreneurship. There are lots of companies coming up with new ideas, new technology constantly. It's a moving science, and it's very active in America. There's lots of websites with companies that do it. There's one company doing it in southern Iraq at the moment on quite a large scale, working with the government. And there's lots of companies in Europe that do it all over the place, mainly for small sites where there was an old contaminating industry, like a refinery or a petrol station or a laundry service that's been contaminating the soil. So we're talking about sites smaller than a football pitch that then want to be developed for housing, or an area that was an old dump that wants to be developed for a new airport or for an industrial site. So often it's a change of land use that stimulates the need to do it. And often it's an old activity that wasn't looking after as products, and they were disappearing into the ground and into the groundwater. So it's a fascinating science. I wish we could talk about it. There's so many different techniques and methods of doing it. But there's a lot on the internet you can find, and there's video clips that show people actually doing it, pumping air into the ground, drilling lots of holes, kind of vaporizing the volatile hydrocarbons and get them out the system, and trapping them in special filters.
Mm-hmm. No, so as Matt said, I mean, this is a whole separate sort of field and subject. And actually, this is something that we will develop as a training course for the countries where we are working under the Oil for Development program. Is this on remediation, site cleanup and remediation, and eventually we will have a webinar on this as well, perhaps next year if there's a lot of interest. But Matt, maybe we mentioned that the Iraq case was more of a rapid assessment as compared to sort of a conventional contaminated site assessment. So I just wanted you to comment on, since you were involved as part of the planning of this work in Iraq, what are some of the key differences, and what are still some of the main common elements that we used and adopted for this rapid assessment?
Well, perhaps but the assessment was undertaken under quite a short time constraint, so that limits the amount of time that the teams can be on site. But from what I've seen, they gathered the appropriate information. They did a fantastic job. to get information from every site. Now the next task would be to put that information together and decide which of the sites which need to be remediated, or which are the, let's say, the hotspots from which you would consider remediation. But before you do that, you have to get into the detailed site assessment. So the next, out of the 74 sites, they may decide that there are 20 sites that are really important because there's human receptors there, or there's business receptors, or there's wildlife or groundwater receptors that need, that need attention. So then they would go the next level and design a sampling plan and get back in the field and take the samples and go to the whole next trip.
Okay, so that's actually the most ideal step. Next step is then, now that they have done this rapid assessment, they have prioritized the hotspot zones. Then they can invest resources in a more efficient way by just focusing on more detailed assessment and sampling in those sites. I think.
Yeah, they need to now develop the conceptual site model for the top 20 sites, for example, and try and understand the volume of the source material that's gone into the environment. Where has it gone? To what depths? Geographically, how far has it spread? And that's quite detailed. The cost of doing a detailed site assessment is significantly more than to do the preliminary site assessment. But you have to do the preliminary site assessment first. It's one of the steps. So now they need to get on to step 2 and do the detailed assessment, and from there develop the conceptual site model that will allow you to think about risks and to think about remediation. It's a long process. The costs go up as you start to think about cleanup.
Yeah. Which is why it's still important to do the site assessment properly, because you're gonna start paying for what you're gonna do after, right? So I think with that, I will close our question and answer forum, and I would just like to thank again our speakers for joining us today, and for all the preparation work that they have done for this webinar. Thank you very much, Mr. Walid Hussein, from the Ministry of Health and Environment, Government of Iraq. Hello, we see you now. And Dr. Matthew Richmond, who is working with us closely. Thank you very much, Matt. And finally, last but not least, thank you, Chidima, for making this run as smoothly as we can, despite our Wi-Fi hiccups. And again, finally, thank you for all of those of you who have stuck around until the end, and I hope some of this discussion was useful to you. And if you are an oil and gas producing country, then I hope you can take some of this learning and knowledge to your professional institutions and practice. I think Chidima has shared the PDF files of the presentations. What we will do is upload the recorded video of this webinar on YouTube. You will receive a message once it's ready, once we have it. So you can watch it again or share it with your colleagues and friends. I would like to also then bring to your attention that Chidima, if she hasn't done already, will send a survey link at the end of the webinar, in order for those who are interested in receiving the certificate of participation. You just have to fill in this survey questionnaire with some questions, and we appreciate your feedback as well. Finally, I wanted to mention that those who have registered for the webinar, we will subscribe you to our monthly newsletter for the Global Network on Environment and Oil and Gas, as we want to disseminate as much knowledge and information related to environment and oil and gas from all topics. So you're also welcome to send us the information. And if you haven't joined us yet, if you follow us or join us on LinkedIn, we're under Global Network on Environment and Oil and Gas, and share your materials, share your experiences. And we'll be doing the same. We'll be sending out materials or knowledge or updates or events that we are organizing. So Finally, I think our next webinar will be in November. We don't have yet an exact date, but we will definitely send it to you, which will focus on oil and gas exploration and production in environmentally sensitive areas. So this webinar will be undertaken together with our collaborating center in Cambridge, the World Conservation Monitoring Center, WCMC, and we will invite other guest speakers as well. So hopefully we will see you again for the next webinar, and please send us your feedback. And with that, I will close this webinar, and thank you again for joining us.